Okay. Uh, Back on Friday. So it's Saturday night. We just got back from visiting my sister, and yeah, son is sleeping and wife's watching Hack-hackety. So why not stream a bit? So yeah, like I said on Reddit, I'm on my Linux partition. If you are interested in what distro I'm running, it's Linux Mint with Cinnamon desktop environment. Nothing fancy, almost default settings. And let's see. I was just doing something here, so I decided why not try how this works. Let me just close any extra windows that seem to have been left open. There we go. Now we can focus. So, right. Yeah, if you're just watching for the first time, we are hacking up a solo card game called Friday. And it's an excellent single-player card game by Freedom and Freeze. It's about Robinson Crusoe, who has just deserted on the awful island and is trying to survive cannibals and wild animals and ultimately fight the evil pirates and maybe get home that way. So yeah, it's a little deck building game. Very fun at that. So we have the rules here. And let's open our Trello. It's here, right. So last time we implemented all of the special abilities of the Robinson cards, including the aging ones. So that's cool. Let's see, can I archive lists? Archive list, excellent. Okay. So now, let's run the game and see what's the state. Okay. Oh, right. Let's create a game capture here. Sorry about the red screen. It should go away momentarily. Any second now. If I could just find the right window. Okay, is it gone? I think it's gone. Okay, I move it there. Okay. Yeah, the game should be on the screen now. The pirate cards here. It should be obvious that they can be drawn quite differently depending on something. So that's one thing to check out. But the game actually gets up to here. You can play the game legit and get up to this point. Now, normally in the game there's only 2 pirates to choose from, but still. Let's pick anything and let's see. Okay, so we have implemented that the pirate card is here, that's the correct background, the fighting value, free cards, everything fine. The special ability should be centered in my opinion, but we'll worry about the layout stuff at a later point, which may not be that late, but oh well. And like we discussed last time, the pirates are hazards, so the fighting is exactly the same as with the hazards. So, oh yeah, the game crashed when trying to draw a card. And now I remember, that's where we left off last time. Okay, I'll just take a sip of water and let's continue. Okay. Sorry about that. Yeah, index can't be greater than or equal to size. Your run-of-the-mill index out of bounds exception. But what causes that? Played cards free. Size. Ah, right. Yeah, this plays. Yeah, this is the reason why I didn't want to separate the current hazard from the current pirate into 2 separate um, um, fields in the game state. So what we could do is create a common interface for the 2. But yeah, no, we're just hacking this up, so free cards. Come on, Eclipse, you can do it. Whoa, that's quite a big content assist. Okay, we'll fix it the next time it comes up. Okay, now. Can I resize it? Yes, I can. Can I? No, I can't move it. No, I have never seen this. That's weird. Eclipse is full of wonders. Okay, now it's sane. Oh well. Okay, and one final thing is if there is no current hazard or current pirate, let's throw a illegal state exception, just because we can and should. No hazard nor pirate. Okay. And now when we run the game, the no. Oh, right, it's totally possible that when is at the beginning of the game. Yeah, that's correct. Right. So game capture, for some reason, oh, um, okay, now it's up. Anyhow, okay. So the game capture shows the game, and now you can draw cards. And nothing has changed. It works exactly as before. So one thing that we are interested in is, can you resolve? No, you can't. Okay, let's fix that. So apparently we're just hunting the places where certain values should be read from the current pirate instead of the current hazard, and that just screams for a common interface. Oh, jeepers creepers. Yeah. But still, the places are very limited, and yeah. Current hazard value. Okay, let's separate that to here. If game state current hazard is not null, subtract that. Otherwise, if the pirate is not null, and the pirate cards never have their hazard value modified. So there we go. Let's run the game. And okay, before we continue with this, I should explain what happened last time. I removed the screen capture. The screen should be black, and now the game capture is set on, and it shows the previous instance of this window. So yeah. So it's safe to assume there's something about the X server apparently that I don't understand, and I think I should. So that's one thing to my to-do list. Okay, so let's continue. Let's engage a pirate, draw some cards, and resolve. Robinson lost against the hazard. Okay, and back to the rules. Let's close the game. One thing I have to check. The bottom 300. Okay. I'm gonna do a small test here. Okay. If we subtract 200 pixels from the game window, I don't have to worry about switching sources, and actually that's a really good thing, because then I won't forget to switch them, which I have done for the last streams. Okay, so back to topic, and yeah, the rules. Let's open the rules, and the pirates. Let's see if I can find the rule. I'm gonna paraphrase it here first. The pirates here. You must win against the pirates. Losing against the pirate results in a game over. So yeah, so we have to implement we have to implement a game over. So let's see, let's go to the game here. Let's okay, so now you can lose to the pirates in a way. Let's seed the scenario with where is it? Here. Let's have a Robinson card with a really large value. So type is anything. Okay. Let's see what happens when you win against the pirate. Okay, this is pretty good. So there's 8 pirates. I'm not totally certain why 8, but we'll roll with it. And draw a card, resolve, and the game crashes, so let's do something about that. Right, there's okay, so game state. Are there going to be any fanfares? Is there something that should happen after winning against a pirate? Let's check the rules. Choose one pirate, place him in front of you, start a fight. As discussed previously, they act exactly like hazard cards, and after you beat the first pirate, you place all drawn fighting cards on the Robinson discard pile and must immediately fight against the other pirate. No, nothing. You just get a pat on the back and you have to fight the other one. And after you win that, you win the game. So let's notify of winning against pirate. Okay. And okay, this is good. Create method for that. Let's go implement that. I mean, it's, yeah. let's put the correct variable name to the parameter. And one final thing is to just actually have the correct text. Pirate defeated. Alright, and no content. So that should be it. Let's try to win against the pirate. Run the game. And still we have 8 pirates. Engage. Draw. Pirate defeated. And now we get to choose from 7. No, still from 8. Huh. Let's see. Whoops. Oh well. We can get the call hierarchy from the interface as well. And oh yeah, yeah. We don't discard the pirate. So game state pirate deck. Do we ever discard the current hazard? Oh, that's a tickler. I don't think we do. Oh well. Let's see, start a round. Here, pirate cards. Right, yeah. The chosen pirate card is not removed from the pirate deck. So that's all we have to do. Game state, pirate deck, stack, remove. Value chosen, false. Excellent. And while we're at it, let's check the game state factory. How does it create the game state? Oh. Oh, that's cute. Dang it. But why? Well, sure, there's 2 pirates. There can never be more. But no, I don't like that. Let's think about this. let's do it like this. All pirates deck. Okay. Excellent. So now we have a deck of cards which holds every pirate card in the game at the beginning of the game. And from there we fill the pirate deck. Let's just remove those. So for there we go. One final thing, create that constant. It can be here. So there's always 2 pirate cards. Excellent. Okay. So now here. Let's run the game. See what happens. So I was just assuming that the pirate deck was, well, the pirates in the game. So yeah. Now we're at a kind of a cool place here. Let's see. Okay, we don't have to do anything about those. So wait, why can't I resize the game? Okay, so yeah, it's the pirate widget for some reason has minimum width, which is crazy long. But hey, we'll do something about that. Let's just draw a pirate card, draw a card, resolve, we defeated it. There's 1 card left, we didn't choose it, we resolve, we defeated it. And here should be the 3rd game over, which is of type victory, of course. So okay, let's commit our changes and think about what to do next. Team commit. Oh, okay. But yeah, it's looking pretty well. So yeah, we have one big question here. Now has come the time, or rather, let's actually think about this. We could solve the game over thing. How we're gonna structure that here, or we could implement the come on brains, implement the pirate specials. Either one. Um, since last time we implemented so many Robinson card specials, it would follow suit that we'd implement specials now. So why not? Let's do that. Trello, where's our Trello? Here. So there's five different specials that the pirates have, and what could be the easiest one to implement? I don't know. Let's start from the top. Drawing costs 2. So you may remember that when you are drawing cards, when fighting a hazard, you can draw one card for each free draw that the hazard has. After that you can still keep drawing, but every draw costs 1 life. But when fighting against this pirate, they cost 2 life. Okay. Let's add a pirate card. With that special. And well, the most simple way to do that is to just go to the place where the life is subtracted and just add the effect there. And that's exactly what we're gonna do. Cause, oh dang, I don't have my motivational text file here, but just get it done, and we are just hacking this up. I want to get this operational as soon as possible so that I can try if it runs on my phone. I could try it now, but I have a weird list of priorities. Okay, let's move on forward. So, drawing costs 2 life. Okay, so let's find the place that modifies life value. Life current. There's only a few places that modify that, and draw a card is one of them. So life lost comes as a perimeter. And what's this? Well, it calls with a 0. This calls it with a 0, so the last place is this. Oh. Well, we already know it's this place. So, yeah. Let's do this the simple way. So if game state current pirate is not null, and game state there we go. That should be it. Let's run the game and find out. the one we're interested in is in the bottom. So there's 2 free draws, so for 2 draws the life total should stay the same. It did. And now clicking this should plummet our life to 18. It did. It works. So should there be a warning of some sort? Maybe. But hey, that's polish. We add polish later. Much like when drawing a card would kill Robinson, there should be a verification question or something like, are you sure? Or just stop it. Downright stop it. Yeah. But we're not gonna worry about that now. That's polish. Okay, so we are happy with the results. Let's commit. Pirate special, 2 life per draw. Done. Okay, let's check Trello. Move that to done, and well, let's just pick them one by one from the top to bottom in the order the rulebook presents them. So the next one is half cards count. So what does that mean? Let's check the rulebook for that. The pirate specials are here. So you can only use the fighting points of half of the drawn fighting cards. All 18 cards have to be used, and if you have an odd number of cards you can round up in your favor, whichever that is. Okay, so this looks interesting. So let's find the place where we calculate the fight total. It's in the player wants to resolve. There. Okay. Calculate fight total for cards in play. We have extracted that to its own method in game state. That's cool. Let's go there. To do implement, well, it's pretty implemented already, but okay, let's do this. And now I don't want to have the player do the calculation. It can be done, it's not too hard, but you know, it's gonna be a lot easier if the computer just tells the result. So what does the calculate effective fight value do? Ah, right. No, this is something else. Right? Is it? You know, it's it's kind of weird to have these old guesses of statuses exist in the code. Let's see, how does it pirate 0 cards? Each drawn fighting card counts +1. Okay, fight against all remaining hazard cards. Okay, +2. Okay, so I thought that it would be cool to have this as a status. Now, it might be, yeah, okay. But I don't want it here. I want it here. So what I want to do is can I? No, well, hold on, let's see. Hmm. All right. Okay, let's return it there. Let's go back to the original idea that I had. Let's follow the original architecture, even if it's dumb or anything. Okay. So we have one method that handles all of the, well, passive modifications to the cards. So we have already implemented one status which sets a card to 0, which is the 18 card, which sets highest natural fight value to 0. But the pirate is a bit different. It doesn't work on natural cards, natural fighting values. So I don't know how different it's gonna be, but let's just write it out here. So pirate health cards count, and well, first things first is just card status is zeroed by pirate is false, because we're updating it. Let's set everything to false and worry about it. Worry about finding the highest, or rather lowest second. So well, this has to be done nevertheless. Or does it? Oh man, you're gonna loop all of the cards all the time here. Fine, let's just do it like that. Okay, so right, yeah, you must use all 18 cards and 18 cards and the best ones. So let's gather the cards into an array that we can sort however we please. Yeah, I know it returns a new array, but it might not in the future. So let's do it here. New array. There we go. Creates a new array containing the elements in the specified array. Excellent. So now that we have that, we can use it here, sure. Cards sort. And create a new comparator here. Whoops, new comparator. Robinson card. Excellent. Okay. And yeah, it's your good old Java comparator. And okay, so and let's say that the highest cards, or rather the cards you want to use, are at the end of the array. So oh, right, but just in case you have a lot of aging cards, I don't know if it's possible, but we have to be prepared for that. So if Robinson type aging, okay, yeah, face card 1 type is aging, and the card 2 type is not aging. So then you return 1. Hold on. So return a negative integer when the first argument is less. Right, and we wanted the used cards at the end, so that's correct. Or is it? Hold on. So if it's not aging, yeah, if this is bigger, -1. If this is bigger, +1. So here this is bigger, so yeah, the other way around. Okay, so those are the easiest cases. If one is an 18 card and the one other is not. Now if they both are 18 cards or not, which is this here, we want to compare the effective fight value. And well, let's see. That's it. Now we have sorted every card so that the 18 cards are at the end and the larger cards are at the end. And now we set status zeroed by pirate to false with everything. And now for the fun bit, which is int zeroed card count is card size divided by 2, and it's an integer division, so it's rounded down. Excellent. So for and the array still holds references to the live cards, so this is going to work excellently. Then if card size models 2 is not 0, is that the correct way to do it? I mean the way everyone else should do it. It's gonna be fine. So so now we find the middle card. It's gonna be that, and if its effective fight value is less than 0, we zero it. Let's just extract that into a local variable. So the middle card. Oh. There we go. And that should be it. Okay, so let's run the game and see what happens. Okay. It's working. Let's draw 118 card and see that as well. Oh, right here. What's happening here? It got zeroed. The fighting cards should be at the end. Okay, so now against the theme of the stream, I'm going to write a unit test here. For this comparator. So let's create a class for it. I mean, that package is as good as any. New class. Pirate half zeroed card comparator. Okay, finish. And go back and copy this. New pirate health comparator here. There we go. What's happening here? Oh, right. Okay. Check the usage one more time. Um, let's actually do this only if there is the horrible pirate in play. So if game state current pirate is not null, and there we go. Let's go do a unit test for that. I feel like I'm letting you down here, but okay, let's move it to the correct place and rename the completion unit. Okay. Let's first just create a very simple sort case, which is okay. So the simplest test case would be I mean, the simple test case that we want to have here is, let's have one of each. So there's two different fighting cards. I mean normal cards, and two 18 cards. That should give us a fair sampling. So let's create our 4 cards that get to be added. Okay. Oh, and right. Add the cards as well. So card 1, card 2, and so on. And now there is the same. Excellent. So okay, I don't know about the indexes yet. Oh, whoops, wrong assert. Let's pick the right one this time. Okay, let's just put these here, and like anytime you're doing unit tests, just run it. Run the unit test, let it fail, and fix the fail. Now, the unit test is not even correct here, but okay, but it gets run. That's good. So the order we want them to be in is the 18 card should be at the end. So 3 and 4. Actually, this this is the order we want them to be in. So does it work? It does not. The error message here is was not. Well, that's helpful. Let's see the line. The first one. And now I have a kindling feeling that I have just mixed up the -1 and +1, but that's exactly the reason I want to do unit tests, because those are easy things to mix up, and without much work we can actually just test if that were excellent. So that's it. That was it. That was the only problem there was, I think. Okay, let's actually run the game and see for ourselves. So let's pick that one and draw cards until we have an 18 card on the table, and it's not zeroed, even though there are smaller cards and greater cards both on the table. Actually, yeah, that's not the reason, but anyhow. I trust that the unit test proves that that works. And we already saw that the ones with the skull don't get counted up to the total. So as far as I'm concerned, for today, this is done. So pirate. Pirate, half of cards count. Select everything and let's go to the Trello. Okay. And let's see. 3 more to go. Cards +1 fight. So each fighting card counts as +1. Starting cards, 18 cards, knowledge cards, and what? Even the turned cards, the destroyed ones. Okay, I have a very strong feeling that I have not been adding +1 fighting point to the destroyed cards, but hey, that's cool. Is that status in the Robinson card? No, it's not, but that's okay. I don't think it really matters if it's not. it might be fun to see, to notify the player that even the destroyed cards have their total upped by 1, but it's just gonna be an icon on every card. And we have the pirate card for that, so now we actually have to pass in the game state here. Suddenly the game state has an effect on the effective fight value of a card. It no longer exists in a vacuum. Well, that's a bummer. Well, this method is called in how many places? 5. So, okay, sure. Let's pass in the game state. If game state card pirate is not null, and as you can see, this is actually a beneficial pirate. But make no mistake, it's not an easy pirate. Okay. And now fix every place that calls it. So here and now the comparator actually needs a reference to the game state, and we can only pass it in through the constructor, which is fine. Assign it into a new field. Let's add a final modifier there. And now to fix that, now we should be done. Oh! That's good enough for the test. Oh, it's not called game state, it's a tableau. Okay. So let's set up a scenario, see for ourselves that it works, which I hope it does. Run the game. Yeah. Okay. Very good. Let's commit our changes. Pirate each card +1. Okay. Next, we have Okay, we have two interesting ones. These actually don't modify your fight totals or how they're counted or how much you pay for draws or so on. These modify themselves, which is kinda neat, but poses an interesting question that where that calculation should be done. Well, the user has to have the information before making the decision or the information that what the value is going to be. Or does it? Well, preferably. Actually, let's not put that there yet. Or should we? I'm really indecisive today. Okay, eeny, meeny, miny, moe. Which one is the easiest to do? Let's do this one. Pick one from the bottom, just for the hell of it. +2 hazard for each aging. So let's look in the rulebook. So its hazard value increases by 2 for each aging card added to your Robinson stack. And let's see. Yeah, even the destroyed ones do. So the rulebook asks you to count the cards in the Robinson stack, and you know we can do that. That's good. Let's do it that way. Now that means that we have to save the number of cards in the aging deck originally. Now that's not going to be a problem. We'll do that. You can count the remaining 18 cards on the aging storage board. Yes. Okay, that's not too bad. So first things first, save the number of 18 cards. Aging deck, there. Great, aging 2, aging 1, okay. So, game, aging deck, original size. There we go. And the pirate card is going to need some modifications. Let's first go here. Choose one card. Here. Chosen fight screen. Okay, and then game state current pirate. Okay. Now what we want to do is have, just in case, original value. Just in case it's it gets this calculation gets called. Several times. I don't know why it should, but it might. So modifies the hazard value and returns it. Should it? Nah, it modifies the hazard value. So each aging card. So game state aging deck original size minus the current size is the number of aging cards drawn. Okay. So, right, one final thing. If pirate special, hold on, grows with aging equals special, then we do this. We don't do this for every pirate. Okay. And the hazard value is hazard value original plus the number of aging cards drawn times 2. And yeah, before you start fighting against this pirate, that's the important bit. It's calculated once. And this should be the same. Oh, actually that shouldn't matter. Okay. So let's run the game and see how this works. So if we just pick it outright, it's gonna be 500. That's the dummy value that the dummy pirate has. But if we instead launch the game, okay, fight against something else first. Let's draw really many cards. Okay, and now we have, let's add one more. So now we have 5 Robinson cards. Resolve this, pirate defeated, and now pick this. It should be 510. It's not, so what gives? Because I picked the wrong one. Huh. Okay, let's try that again. Note to self, read what's on the screen. So, oh, right, yeah. So it's drawn +1, okay. And let's just get, let's get a few. 2 is enough, 3 is enough. 3 is a good number. 3. Resolve, pirate defeated. And here, grows with aging. Engage, and 6. Right, because it was 0. So, it works. Let's commit our changes. And while we're at it, remaining hazards. So what does that do? You pick all of the hazard cards remaining undefeated, and this card's hazard value is the sum of the red values from those cards. And the same is for the free draws. Okay. So we actually have to rename this method. Okay. There. Public int free cards original. Okay. So let's loop the hazard deck. Both the stack and the stack and the discard. Yeah, just in case both. Okay. So we want a method in the deck that returns every card. So let's create one now. The initial capacity needs to be... Can I make a copy of one of the arrays? Okay, this is gonna be just fine. Okay. And we want the red hazard value. Okay. And these actually become the correct values for the pirate. So Okay, so mm, let's set up this scenario once again. Here. Run the game. Okay, equal to remaining hazards, 0 and 0, but if we engage, suddenly it's 198 and 70, with no free cards remaining. Well, that's a bummer. Okay, so when is that set? Current, oh, here, yeah. And now it should work. So that was a really minor error. So equal to remaining hazards. 73 draws. God damn, that's cool. Okay. You know what? We did it. That's the last pirate effect. And I have half an hour to fill. So, we were contemplating before we started implementing the pirate specials that if we should do that or if we should either handle the game over states somehow. And that might be a good one to do. Right. We know there's 3 game over states. Either you win, or you lose against a pirate, or you go to negative health. So there's 3. Let's check the code. Now we have a very clear understanding on where the player can lose against the pirate or win against the pirate. And yeah, let's think about this for a very small moment. Okay, so the controller, this is the fight screen for the entirety of developing this app or this game. I have been doing the fight screen, and I've begun to think of it as the game. But there are other screens, and there is actually something that creates creates the controller. So when it creates the controller, it passes in a callback for when the game ends. Actually, when the fighting ends, Now that I think of it, the fight screen was supposed to be just one fight. Now it handles the game. Hmm. That's fine. That's totally fine. The game is just fighting, anyways. So, okay. Um, Here, fight screen controller. Does it already have a constructor? Yes, it does. And game over handler. Okay. Let's go here. So pirate. Here, live current. So okay, sure, let's do it here. If game state live current, should we? Yeah. Let's just do it like this. So if it's -0, -0, it's less than 0. Game over handler live negative. And return. Okay. And let's add that to return. Do we want to return? No. No, that's not what we don't. We just want to inform the game over handler that life is negative. Do what you want. Okay. Let's find the other places that the life can go down. Not there. Draw a card. Excellent. Do I have to refresh that? Yes. Okay. That's already done. This one. So there's... Is there really only two places that modify live current? Draw a card and player wants to resolve fight. I'm not buying that. There's the life modification here, this one. Yeah, so why doesn't... What's happening? I didn't scroll low enough. Now that should be a sign for me that it's getting late. But not just yet. Okay. There we go. And controller, game over handler, and we need to make it public. Sure, let's do that. Okay. And then we want to inform the game over handler um, when the player would lose against a pirate, which happens here. Robinson lost there. And if game state current pirate is not null, let's inform the handler. Lost against pirate. Okay. And one final place is the victory, which happens not here, but here. Against the pirate, it gets discarded, notify of winning against pirate, and then should I do it at the start of the round? No, let's do it here. So if game state, no, this demands too intimate information about how the start round works. So here, pirate. Stack, okay. So if pirate cards size is greater than 0, do that. Otherwise, win. Should I pass in the game state? I'm thinking yes. We can always remove it if we don't want. Change method, yes. Okay. And now implement a game over handler. Fight screen alpha. Now that's a beautiful name. Okay, so it's a libgdx screen. Screens are a neat way of organizing your, well, game screens in your libgdx game code. There's it's kind of a utility class, which is, if I may show you, oh right, screen is, well, it's a good interface for a screen. Screen adapter, that's the default screen. No, okay, so I remembered wrong that it was anything more than just the screen. The neat thing is in where here in the Friday game, this is the game class. You don't have to use the libgdx's game class, you can use application listener. There's certain differences. I'm not going to list them here because apparently I remember stuff wrong. But yeah, here's the fight screen. And yeah, it's the game has, libgdx game has this screen handling functionality to it, which is really neat. You can organize your stuff into logical screens and just set the screen you want to be on. It's neat. And the game class handles calling hide. I have the Javadoc here open, but it calls hide on the old screen, sets the current screen, and calls show on the new screen and starts updating that instead of the old screen. So yeah, it's a lot of, you could say, boilerplate code that you'd have to do for every single project if you liked organizing your classes like that. So yeah, it's neat. But yeah, back to topic. When the game over happens, we actually want to change the screen. So add argument game over handler. Should we move it to 5 screen alpha? I'm thinking yes. So let's yoink that away from there. Okay, and we want it as a perimeter. So assign to a new field. No, to that field. And that should be it. Oh, right. We have to organize imports here as well. And that should do it. Except for the game, of course. So, and let's go the super simple way about it, which is start new game method here. Okay, and call that here. New game over handler. There we go. That should do it. Okay. And now what we can do here is show loose screen. It's gonna be the same one for those. Let's just put a print line there. Okay, so let's create the loose screen. This is gonna be exciting. Create a method, not in there, but here. And hold on, does it remember screen height, screen, right, yeah. It only keeps a reference to the current screen, so that's great. No memory leaks there. Loose screen, we need a new screen. Here. So let's create a new class called loose screen. Screen adapter is a good super class. And there you have it. Let's just do a placeholder that will serve for a while. So okay, I have to cheat a bit and check here. Not in the dispose, but in the constructor. Okay, let's just do it the way we do it here. Now, I'm thinking that a single sprite badge in the whole game might be sufficient here, since we're not doing anything too wonky with it. But yeah, let's not. That fight UI is what is it? It's the scene stage, right? Stage. Okay, let's just create a scene 2D stage with the text that you lost and the button to restart. So it's going to be something like this. Let's go here, public, loose screen. We want the skin. We want the stage. Let's cheat and check how we did it in the fight UI. Here it's a screen view part and there's nothing else there. Okay. And yeah, the input multiplexer is something that could be shared. Maybe. Oh well. Okay, and let's cheat a bit more, and we want to have these as well. Okay, remove that, remove that. Maybe we don't need them. And okay, so now all that's left is construct layout. Okay, so handler, yeah, into a new field. Oh, there is already a field. Okay, because I just did it. Okay, so stage. This here. Let's use the table because it's really good. 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 Good widget to have. Okay. Actor and table fill parent true. There we go. Okay, and just some content. It really doesn't matter what. So hard-coded strings and loose screen, generic text. This is starting to shape up pretty well. Call span is 2, because we're gonna... Should we? Yeah, let's do it. Okay. Expand and fill. There we go. Table and row. So a new row begins. And then table add new, let's say, button. Okay, let's button with image and text. That's the one we want. So icon ID is, so we want 2 buttons, restart and quit, and we can use the existing, any existing icons there. It really doesn't matter right now what we use. Blue screen, restart, skin and asset provider. There we go. Robinson stack. Okay. Oh, this needs the asset provider. But of course. Okay, so now we have it. Okay. And I want to check the Fight UI for the buttons at the bottom. They have, yeah, I'm not too hot on just copying everything, but this is fine. Okay, let's have that there, and then we also need the height. Okay, and the same ones here, and that should be it. Is that a button? It is. Okay, so Let's extract them. Oh, dang it. Extract the button. I should have thought about this earlier. Okay, so that's the restart button. And this here is the quit button. Let's wire them up here. So restart, add click, add listener. Yes, new click listener. And we actually have to override the correct method, which is this one. Okay. One for the quit as well. And what we want to do is handler start a new game and handler quit. And that should do it. So, did we already fix the constructor? No. Yeah, because we don't use it anywhere. Okay, so it's the... where is it? Friday game. Show lose screen. So, set screen new lose screen skin asset provider new lsbch. Okay, and a semicolon there. And now we can just call the start a new game method here. Dang it. Here we go. Okay, so now if we run the game, we can actually lose for the first time. At least for negative life. So let's try that. Draw, 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 draw. We're losing life fast. 4 more. 2, 1, 0, and moment of truth. Obinson has perished. Oh, right, So if we click this, which should read restart, the game restarts, most probably. Fun, right? Okay, so did we forget to set the text here? Yes, we did. Okay. There we go. Is it easy to center align the label? Oh, yeah, it's actually... I don't know. I'm gonna check that out someday, but this is the easiest way to do it. So now we'll lose too little life. this is an excellent... Oh, whoops. Excellent opportunity for me to drink some water. Okay. And Robinson has perished. That's kind of gloom. I mean, gloomy. Okay, I love it. Let's check one more thing, which is losing against the pirate. Because that should be identical. I mean, there's really nothing to test, but I mean, there's always something to test. But okay, so at least one. Yeah, sorry. Whoops, we defeated that. Didn't mean to. Still didn't mean to defeat that. That's okay. Okay. Quit doesn't do anything. Let's commit our changes. Okay. And yeah, while we're at it, let's do the game over victory. Windscreen. Let's first of all put a notice here that copy of loose screen combine. Okay. And it has to be a string, and then okay, that's good enough. And yeah. Okay, you know what? Just for the giggles, let's add a fun little icon. Yeah, this is great. SVG. There we go. Open the asset pipeline, or whatever you would want to call that. Let's see if this works. Show in System Explorer. Opening. It thought about it long and hard, but no, it did work. Excellent. Okay, let's add the balloons there. Pasting, no. There we go. Change the name. Okay. And now refresh that and run the pipeline. Was it in plural? Yes, yes it was. Okay. That's that. And let's add it to the screen. And now instead of here. Text with image display, that's the widget. There's two different constructors. We want the first one. So the, oops, icon ID party. Now let's see the scenario so that there's only the two pirates that there's supposed to be. Run the game, and we should be partying ourselves. Okay, draw a card, win, draw a card, and now we win the last pirate. Pirate defeated. And we won, we got a system out print line. Whoopsie daisy. Okay, so show windscreen. And that should be called in the game over handler here. Let's create the quit method in there, and you know, those handlers are identical. Ugh. Public void quit. Is there a quit method? Okay, I promise I won't be long, but let me Google that real fast. libgdx game quit. There has to be, right? Real closing, okay, fine. Loading, loading, loading. And GDX app exit. Let's do it like that. Here we go. App exit. So now that works as well. So one final thing is, let's see for ourselves that the windscreen works and the quit button works. Part defeated. Robinson has escaped the island's little party there and quit. Excellent. Okay. Let's check our Trello. Because the situation now is that we get to do polish. The game works now, and it has all of the rules. And yeah, the rest of the development is going to be polish. So yeah, that's pretty neat. Okay, and in addition to checking the Trello, let's check the time. It's almost 11 p.m. It might be a good time to call it a night. We